Good morning to all of you. Today we are going to do some examples related to areas of circles. First example is the radii of the two circles are 19 cm and 9 cm respectively. Find the radius of the circle which has circumference equal to the sum of the circumferences of the two circles. Here C1, C2 are the two circles with radius 19 centimeter and 9 centimeter, and we have to find the radius of a new circle whose circumference is equal to the sum of the circumference of the first and second circle. Now for the circle C1 means first circle, radius is 19 centimeter, so the circumference will be 38 pi, and for the circle 2 radius is 9 centimeter, thus the circumference will be 18 pi. For the circle C, circumference is 2 pi r, but according to question this 2 pi r is equal to 38 pi plus 18 pi. We can write it as 56 pi, cancel out pi by pi, so the radius will be 56 by 2, which is equal to 28. So the radius of the new circle will be 28 centimeter. Next example, the wheels of a car are of the diameter 80 cm each. How many complete revolutions does each wheel make in 10 minutes when the car is traveling at a speed of 66 km per hour? Here the diameter of the wheel is 80 cm, therefore radius is 40 cm. The speed is given 66 km per hour. I have changed kilometer in centimeter and hour in minute. So we will get 1,10,000 centimeter in 1 minute. We have to find the number of revolutions in 10 minutes, that will be equal to the total distance covered in 10 minutes by the distance covered in one revolution. This will be equal to 1,10,000 into 10, because in 1 minute it was 1,10,000, but we have to find in 10 minutes, so we will multiply by 10. Divide by the distance covered in one revolution. In one revolution it means we will find 2 pi r, the circumference of the wheel. After putting all the values, we are getting it is 4,375. It means 4,375 revolutions each will make in 10 minutes when the car is traveling at a speed of 66 km per hour. Next example, the length of the minute hand of a clock is 14 cm. Find the area swept by the minute hand in 5 minutes. Now this is a clock and this is a minute hand with 14 cm. I can consider it as a radius. When it will cover an area in 5 minutes, that will be a sector. So we should know what is the central angle, because radius already we know. So the central angle swept by the minute hand in 60 minutes is equal to 360 degree. Therefore the central angle swept by the minute hand in 5 minutes, that will be equal to 30 degree. So the area swept by the minute hand in 5 minutes, that will be equal to the area of the sector with the central angle 30 degree. And the formula for the area of the sector is theta degree by 360 degree into pi r square. After putting the values, we are getting 154 by 3 centimeter square. That is the area swept by the minute hand in 5 minutes. Next example, in a circle of the radius 21 centimeter, and r subtends a right angle at the center. Find the arc length. Here this is a circle. The radius is 21 centimeter. Central angle is 90 because right angle. So it is a sector. But because of 90 degree, we can say it as a quadrant also. Here radius is 21 centimeter, theta degree is 90 degree. So arc length APB, this is the arc length, and this is the part of the circumference, and the formula for the arc length is theta by 360 into 2 pi r. After putting the values, we are getting arc length is 33 centimeter. Now area of the sector formed by the arc. This arc is making this sector. We have to find its area. Same, theta is 90 degree, r is 21 centimeter. Area of the sector is equal to theta by 360 degree into pi r square. By putting all the values, we are getting 693 by 2 centimeter square. This is the area of the sector formed by this arc. Next, find the area of the segment formed by the corresponding chord. If we will join A to B, this will be a chord. So this will be the corresponding segment, and we know its formula. We can find the area of the segment by subtracting the area of triangle from the area of the sector. So area of segment APB is equal to area of sector AOBP minus area of triangle AOB. So theta by 360 into pi r square, that is the area of the sector, and 1 by 2 r square sine theta, that is the area of the triangle AOB. Now put all the values and solve. You will get the answer is 126 centimeter square. Next example, a horse is tied to a peg at one corner of a square shaped grass field of the side 15 meter by the means of a 5 meter long rope. Find the area of the part of the field in which the horse can graze. Now this is a square field. Its dimension are 50 meter into 50 meter. Here the horse is tied with a rope and the length of the rope is 5 meter, and you have to find the area of the part of the field in which the horse can graze. Now this is the part of that field in which the horse can graze, and this is looking like a quadrant with radius 5 meter. So the area of the part of the field that the horse can graze is equal to the area of the quadrant ACPB, that is equal to theta by 360 into pi r square. By putting the values, I am getting 19.625 centimeter square. And the second part is the increase in the grazing area if the rope were 10 meter long instead of 5 meter. Now this time the rope is increased. It is 10 meter now. In the first case, the length of the rope was 5 meter, but here the length of the rope is 10 meter. Means we will solve in the same manner. We will find the area with the radius 10 meter and we will subtract from that area to this area. Now the area of the part of the field that the horse can graze is equal to the area of the quadrant AQSR. By putting all the values, it is 78.571 meter square. But we have to find increase in the grazing area, that we will find by subtracting both areas, and that will become 58.929 meter square. Next example, a brooch is made with the silver wire in the form of a circle with the diameter 35 millimeter. The wire is also used in making 5 diameters which divide the circle into the 10 equal sectors as shown in the figure. Find the total length of the silver wire required. Now the silver wire is used to make the circle. It means we will find 2 pi r, and there are 5 diameters. So the total length of the silver wire required will be circumference of the brooch plus the length of the 5 diameters. 2 pi r plus 5 into d. Put all the values. We will get 285 millimeter. The next part is the area of each sector of the brooch. See here, there are total 10 sectors and we should know the central angle. We know that the total angle is of 360. So we will divide 360 by 10. We will get 36 degree. So the total angle at the center is 360 degree. Therefore the central angle of each sector will be 36 degree. Here radius is 35 by 2 millimeter. So the area of each sector will be theta by 360 into pi r square. Put all the values, you will get your answer. Next example, a round table covers has 6 equal designs as shown in the figure. This is a round table and there are 6 equal designs it means hexagon is here. This is regular hexagon. If the radius of the cover is 28 centimeter, it is 28 centimeter, you have to find the cost of making the designs at the rate of rupees 0.35 per centimeter square, and you will use the value of root 3 here, 1.7. Now if we will join all the radius, then we will find there are 1 2 3 4 5 6 equal sectors, but design is here, this is looking like a segment, so we will find the area of 6 segments. For this we will require the central angle. The total angle is 360 degree and there are 6 equal sectors, so we will divide 360 by 6, we will get 60 degree as the central angle. So the area of the design of the table cover will be 6 into area of one segment APB, and area of the segment APB is equal to area of the sector AOBP minus area of triangle AOB. Theta by 360 into pi r square minus 1 by 2 into r square sin theta. Put the values and solve it. You will get 77.46 centimeter square. But it is the area of the segment APB. We have to find the area of the design. So the area of the design is equal to 6 into 77.46 centimeter square. That will be equal to 464.76 centimeter square. Therefore, the total cost of the making design, that is rupees 0.35 into 464.76, it will be rupees 162.66. Now areas of the combination of the plane figure, we will do it in the next video.